Okay, good afternoon, everyone. We'll start our session, today's session. This one is the our last session of this robotics and artificial intelligence. हा रोबोटिक्स आणि आर्टिफिशियल इंटेलिजन्सचा हा शेवटचा सेशन आपण आज कंडक्ट करतोय. Okay, in that we will go through it, the syllabus, which one is the remaining from this, and we will cover that syllabus today. Okay, the subject title is unit title is kinematics, dynamics, and control. Okay, out of that, in previous lectures we have covered the kinematic part, dynamics only, this trajectory planning. Okay, this part is remaining from our third unit. Okay, today we will finish this trajectory planning and we will end our third unit of our robotics and artificial intelligence. आपला तिसऱ्या युनिटचा जो काही पार्ट राहिलेला आहे तर तेवढा आपण आज कव्हर करूया आणि आज आपण काय करणार आहे तर हा चॅप्टर एंड करणार. Okay, in dynamics, in kinematics, we have seen the forward kinematics, inverse kinematic for 2 degree of freedom, 3 degree of freedom, and planar manipulator. As well as we have seen the sum of numericals on this forward kinematics and inverse kinematic for 2 degree of freedom and 3 degree of freedom. As well as in previous lectures, we have seen the dynamics. In that dynamics, we have seen the velocity, again control architecture of robots, overview of advanced control techniques such as force control, PID control, adaptive control, and PWM control, pulse width, okay, controller. Okay, how to control that pulse width, okay, with the help of this controllers we have seen in the last lecture. Okay, now we'll start with the trajectory planning. Okay, we'll go to that trajectory. Okay, we have seen what is meant by kinematic. Okay, after that we have studied kinematics, forward kinematics, and inverse kinematics. Okay, in forward kinematics we are finding the end effector position. Okay, suppose you want to find the end effector position. In that case we are using the, okay, this position from the base. If you want to find out of this robot, then in that case you can use this forward kinematics. And in inverse kinematics we are finding the angles of joint angle of each link. Okay, प्रत्येक लिंकचा आपण joint angle find out करतोय. Okay, suppose this link number 1 and the link number 2, the angle it is made by these two links are the Q2. Okay, and if you see with respect to base, this link number 1 has a angle of Q1. Okay, Q1 एवढा काय आहे तर तुम्ही त्या ठिकाणी angle बघू शकणार. Okay, now this already we have discussed. Again, direct kinematics. That forward kinematics also it is known as a direct kinematics. Okay, you might be in exam, might be you confused what is mean by direct kinematics, forward kinematics. Okay, direct and forward both are same one. Okay, there is only word differences are there. Okay, we have seen the what is mean by forward inverse kinematics. Okay, again we have seen the derivation of forward kinematics of 2 degrees of freedom robot. Problem we have seen. Next, problem on forward kinematics of 2 degrees of freedom, forward kinematics of 3 degrees of freedom robots we have seen, inverse kinematic of 2 degrees of freedom robot. Okay, geometric transformation we have seen. Okay, this part also we have seen in last lecture. Homogeneous coordinates problems we have seen on that. Okay, these are the problems. Again, it is which is previous we have seen that one. Okay, I have just copied from book. Okay, next, dynamics. Dynamics we have seen related to Okay, inverse dynamics and forward dynamics. Forward dynamics कशाला म्हणायचं, inverse dynamics. Again, we have seen a robot arm dynamics. Okay, this already part we have covered. Next, control architecture of robot. In that, linear controls we have seen. Control techniques, okay, like PID, joint controller, force controller. This already we have seen. Now we are moving towards this motion or trajectory planning. Okay, in motion or trajectory planning, in what we are doing, we are just finding the path of from start to end. Okay, we are finding the path of the robot from start to end. Okay, suppose here you can see in this animation, from green color the robot will start and end with this, okay, position. Means this motion or the path followed by this robot, it is nothing but our motion or trajectory प्लॅनिंग. म्हणजे काय म्हणतोय, सगळं एकदम सिंपल भाषेत सांगता येईल तर आपल्याला, तर ह्या रोबोटनी जी काय मोशन केलेली आहे स्टार्टिंग पॉइंट पासून एंड पॉइंट पर्यंत जी काय मोशन फॉलो केलेली आहे किंवा जो काय पाथ फॉलो केलेला आहे, त्या पाथला आपण काय म्हणतोय तर ट्रॅजेक्टरी ऑफ दॅट रोबोट और मोशन ऑफ दॅट रोबोट असं म्हणतोय. ओके, हियर ऑल्सो दॅट वन आय हॅव रिटन, trajectory planning for industrial robot consist of moving the tool center point. Tool center point means end effector. आपला ह्या ठिकाणी काय, tool center point म्हणजे काय असतो आपला end effector from point A to point B. Suppose this one is the point A. Okay, initial point is A and the moved point is B. Okay, while avoiding body collisions over time. ओके, म्हणजे त्या ठिकाणी काय म्हणतोय तर बॉडी, ओके, ज्यावेळेस मुवमेंट करते ए पासून बी पर्यंत, तर त्यामध्ये असं कोणताही फ्लक्च्युएशन किंवा त्या रोबोटच्या लिंक मध्ये कॉम्प्लिकेशन येता कामा नाही की त्या मुवमेंटला. ओके, ओव्हर टाइम essentially trajectory planning encompasses path planning in addition to planning how to move based on velocity, time and kinematics. म्हणजे this in trajectory planning we are going to study path of robot, okay, path of a robot which is based on velocity, time and the kinematics. Velocity and time आणि kinematics बद्दल आपण त्या ठिकाणी डिस्कस करणार. Okay, now there are two methods of this trajectory planning. Which are those? First one is the joint space and second one is the Cartesian space. Okay, दोन मेथड आहेत. तर ते म्हणजे कुठले आहेत, तर पहिली आहे जॉइंट स्पेस ट्रॅजेक्टरी प्लॅनिंग and second one is the Cartesian space trajectory planning. In joint space description, okay, what is meant by joint space? Now we will discuss. Okay, joint space म्हणजे काय आणि Cartesian coordinate Cartesian space trajectory planning मध्ये आपण काय करतो एक्झॅक्ट पहिल्यांदा स्टडी करूया. ओके, you can see in joint space trajectory planning we are deal with, okay, motion of the robot made by the motion of the robot made by the robot by its joint values. Okay, once again I will repeat, in joint space trajectory planning we are dealing with motion of a robot made robot by its joint values. ओके, म्हणजे त्या ठिकाणी काय डिस्कस करतोय तर इन जॉइंट स्पेस ट्रॅजेक्टरी प्लॅनिंग वी आर डीलिंग विथ, ओके, मोशन ऑफ द रोबोट बाय इट्स जॉइंट व्हॅल्यूज. म्हणजे त्या एखाद्या रोबोटची मोशन आहे तर त्याच्या जॉइंट व्हॅल्यू वरती कशा पद्धतीने मोशन होणार आहे, तर असे जे काही प्लॅनिंग असेल तर ते कशामध्ये येणार आहे तर जॉइंट स्पेस ट्रॅजेक्टरी प्लॅनिंग. अँड इन कार्टेशियन स्पेस trajectory planning, in Cartesian, the name itself you will understood. Okay, what is meant by Cartesian? The moving of the end effector with respect to, okay, our coordinates. Okay, which are the coordinates? X coordinate, y coordinates and z coordinates. Okay, जर एखाद्या रोबोटची एंड इफेक्टची मुवमेंट अलॉंग एक्स वाय आणि झेड डायरेक्शनने जर होत असेल तर अशी जे काही रोबोट असणार आहेत तर ते म्हणजे असणार आहेत कुठले तर कार्टेशियन स्पेस. Okay, Cartesian space okay, that path we can define with the help of Cartesian space trajectory planning. I will show you that two joint space and Cartesian space. Okay, both robot working animation with us. Okay, just I will show you that animation. Here you must understood in joint space the motion to be made by the robot by its joint values. Okay, motion of the robot, it is made by its joint values, and here the motion between the 2 points known as all times of control level. Which are the 2 points? One is the base and end effect. या दोघांमधली जी काय मोशन असेल तर ती कशामध्ये आपण डिफाइन करतोय तर इन कार्टेशियन इट इज इझी टू विज्युअलाइज द ट्रॅजेक्टरी बट डिफिकल्ट टू इन्शुअर दॅट सिंग्युलरिटी. ओके, म्हणजे इझिली आपण अंडरस्टूड करून घ्या आपण वेदर इट इज कार्टेशियन और द समथिंग एल्स. ओके, हियर यू कॅन सी हियर सिक्वेन्शियल मोशन ऑफ अ रोबोट टू फॉलो अ स्ट्रेट लाईन. ओके, एक स्ट्रेट लाईन तुम्हाला त्या रोबोटच्या साहाय्याने मूव्ह करायची असेल तर त्या केसमध्ये यू कॅन सी हियर the motion like this, that arm motion you will find such a manner. Okay, the Cartesian space trajectory A, it will represent the trajectory specification in Cartesian coordinate may force the robot to run into itself, and B, it shows the trajectory may require sudden change in the joint angle. Okay, here you can understood at certain level we require to change the angles. This one is the come under the joint space and this comes under the, okay, means if the values are changing, joint values are changing, then we can go for the joint space Cartesian, joint space Cartesian, joint space Cartesian, we can say that joint space trajectory planning. If the motion between base and this end effector, then these are the Cartesian coordinates. Okay, just I will show you the animation of that one. Just open. Okay. Okay, here you can see. Just wait a minute. Okay. Let it be. You can see here. Okay, this one is the, okay, the first robo is, okay, here you can see this first robo, we can say that it is Cartesian robots, and this one is the, okay, means each angle having in Cartesian robot we are deal with the this position or the motion of end effector and the base. Okay, you will find it will move this robot along x axis, y axis and inclined one, but here you will find here at a certain level it will change the motion. Okay, तुम्ही जर ह्यामध्ये बघितलं तर मोशन मध्ये चेंज झालेलं तुम्ही त्या ठिकाणी बघू शकणार. Okay, I hope you understood this. This comes under the, okay, this robo comes under the joint space and this one comes under the Cartesian coordinates. Okay, Cartesian and joint space. Okay, next one is the motion of trajectory planning. The why it is required this trajectory planning. Okay, we will just understood. I have written some of related to that. The goal of motion planning of a robot is to generate a function according to which a robot joint will move. म्हणजे त्या ठिकाणी हे कशासाठी लागणार आहे तर हे ह्याचा गोल काय असणार आहे किंवा मोटो काय असणार आहे तर ट्रॅजेक्टरी प्लॅनिंगचा तर मोशन प्लॅनिंगचा और ट्रॅजेक्टरी प्लॅनिंग ऑफ रोबोट टू जनरेट फंक्शन अकॉर्डिंग टू विच रोबोट जॉईंट विल मूव्ह. म्हणजे जशी आपण पोझिशन किंवा मोशन आपण त्या ठिकाणी रोबोटला देणार आहे तर त्या पद्धतीने ते वर्क होते का नाही हे आपण त्या ठिकाणी ह्या ट्रॅजेक्टरी प्लॅनिंगच्या साहाय्याने आपण फाइंड आउट करू शकणार आहे. दिस फंक्शन जनरेशन डिपेंड अपॉन द रोबो टास्क. ओके, हे कशावर डिपेंड असेल? इट डिपेंड अपॉन द रोबो टास्क. ओके, व्हॉट इज टास्क गिवन फॉर दॅट रोबोट. सपोज फॉर एक्झाम्पल, पिक up an object from one point to place it is in another point, or to weld two metal pieces along a curve. Okay, आता ही पाथ कशावर डिपेंड असणार आहे तर इट डिपेंड अपॉन द ऑपरेशन परफॉर्म्ड बाय दॅट रोबोट. ओके, आता सपोज एखादा रोबोट पिक अँड प्लेस असेल तर त्या केसमध्ये काय असणार आहे तर वी जस्ट पिक अप दॅट ऑब्जेक्ट फ्रॉम वन प्लेस अँड वी आर प्लेसिंग टू द अनदर. ओके, और सपोज वन वेल्डिंग रोबोट इज देअर. ओके, वेल्डिंगचा रोबोट असेल तर त्या केसमध्ये काय असणार आहे तर वी हॅव टू वेल्ड इन सपोज कार बॉडी यू आर गोइंग टू वेल्ड, then that cardboard body is not in a straight line. Okay, that robot motion must be in a curved manner. In that case we have to use this trajectory planning, or we have to define the path of that end effector. End effector चा path त्या ठिकाणी define करणं. In the former cases, initial and final points are assigned, that is point to point motion, where in the latter situation of finite sequences of points need to be specified, that is continuous path motion. A robot user typically specifies a number of parameters to describe a point to point or continuous path motion. Okay, sometimes we require to move the robot point to point, or sometimes we have to require to move the continuous path. Point to point where we can use pick and place robot where required point to point motion, and in welding we require the continuous path motion. ओके, तुम्ही जर बघितलं असेल तर पिक अँड प्लेसचा जर रोबोट असेल तर त्या ठिकाणी वी हॅव टू यूज ओके पॉइंट टू पॉइंट मोशन, अँड in welding operation we have to use the continuous path motion robots. Okay, next one is a robot user typically specify number of parameters to describe point to point or continuous path task. An algorithm then computes the input from the motion controller of the robot. Motion planning, which is also referred in literature as a trajectory planning, can be done either in the joint space, that is in terms of joint position, velocities, acceleration, Cartesian space, that is in terms of end effector position, orientations, their time derivation. Usually the latter is preferred by an operator since it allows a natural description of the task that robot has to perform. However, the control action on the robot is carried in the joint space. The suitable inverse kinematics algorithm is to be used to reconstruct the time sequence of joint variables corresponding to the above sequence in the Cartesian space. Okay, next one is the first one is the joint space plan. पहिली जी आहे तर joint space plan. Just before that, we'll see one video related to joint space and the Cartesian space. Means we can understood that. Okay, joint space and Cartesian. Just
अगर मैं आपको बोलूं कि आप
trajectory planning. Trajectory planning. So applications is task over a particular function. Trajectory planning means finding the movement pattern to achieve a task. The goal of trajectory planning is to describe the manipulate as a of join, link, vector locations, and derivatives of which are generated by interpolating or approximating the discrete path by a polynomial function. First, what are the terminologies used in trajectory planning? In this, we have path, trajectory, north points, or via points, or interpolation points. First one is path. A path is the locus of points to be traversed by the manipulator to execute a specific task. Trajectory. A trajectory is a path with specific a path on which time is specified in terms of velocities and accelerations at points. In other words, a trajectory is the time sequence of motion, velocity, and acceleration for each joint or vector of the manipulator. North points or via points are interpolation points. These are a set of locations between the start point, destination point on the trajectory to which the manipulator must pass. Next, steps in trajectory plan. First one is task description. Next, a trajectory planning topic. Third one is computing trajectory. Next, task description. What is task description? The first step in trajectory planning is to identify the kind of motion required. The kinds of motion commonly encountered are point-to-point P2P motion, continuous path motion CP, and motion with more than 2 points specified, point-to-point with via points. First, what is point-to-point motion? The initial and final vector locations are specified. This lot of features what the part are fixed destination points. Such as suitable for simple. Next one, in continuous path motion, in addition to start and end points, the path to be traversed by the arm is also specified. This type of motion is suitable for applications as another type of motion is one where more than 2 points of path are specified. This is point-to-point motion, which ensures better motion of the executed task. It is suitable for pick-and-place applications with extended pick-and-place points. First, selection techniques in trajectory plan. In this, we have two types. First is joint space techniques, Cartesian space techniques. The selection of the technique depends on the nature of the task. For P2P motion, with or without via points, joint space techniques are employed wherein the motion plan is done at joint level. For continuous path motion, Cartesian space techniques are used wherein the motion planning is done at end effector level. In this case, the joint variables required to achieve a desired end effector location is which is from inverse point.
Hello and welcome to the MATLAB simulation only. It's a set of points that will link between a start and a goal pose, for example. Whereas a trajectory that with the task-based trajectory, some redundant degree application while it blends. And also this trapezoidal or polynomial trajectory in Ross to then now you'll see that the following problem is a little bit different. And our robot is now going to this last waypoint that we introduced up here. And then I can always, also remove waypoints, republish, and then see how that changes the problem. And right now we have a MATLAB app talking to Simulink, but for
next, how to compute the trajectory. The final step in trajectory planning is to compute the time sequence of values attained by the function generated from the trajectory planning. Here we have two types. First one is joint space, second one is Cartesian space. What's the difference between in Cartesian space, it takes into account.
Okay, you go through it. Actually, there is no specific. We can say that video it is related to that joint space and Cartesian. Just I want to observe you how that exactly that robots are. Here it may be.
With the rock-block quick change system from Fifth Axis, you can simplify your programming.
Hey guys, Adam, user advantages. Center line of tutorial series. But let's
Here you can observe.
Let's start messing with.
Okay, here you can find the
As I'm
joint representation.
This robot right now, I have it. with
You can
the
see here.
view
You will
facing
understood.
in- facing at the table. I'm gonna grab J4. J4, and I'm gonna go up.
This one is the joint space.
All I did was invert the whole wrist assembly upside down. It puts the gearbox on the outs away from the table. And now I'm gonna grab J5 and just put it back down. And look at that. I right back exactly where I began. Look at the difference. F. Instead of a NUT, meaning not split, it's an that's because if I were to look at this thing Cartesian,
Okay, these are
this
the
is
Cartesian
actually
with
more
respect to
massive.
base. This
This
position is calculated.
space
The
that
end of
proves that
here at that point they have shown.
Where's the base of the robot? So
Okay,
that's
here
one
you can see
example
also.
of
Here also it is written with respect to this base in Cartesian coordinates.
Another question, this should be your first follow-up question, is do I need to use a joint command to go to a joint position?
Okay, let it be. This is. I want to just show how to that joint space and the. Just remember that if with respect to joints, the in Cartesian just we are doing in the form of coordinates. Okay, जे काही coordinates are along x, y, and z. The motion or the path, if you want to find, then in that case we can go for the Cartesian space, and in joint space, okay, in joint space, the depend upon the angle. In this section, method to determine a described trajectory of motion variables over a time are considered. In this joint space scheme, it is assumed that the initial and final joints position are given or calculated from corresponding initial and final configurations of the end effector, or are known for from the inverse kinematic solution for position. Okay, joint space in that we are doing similar to inverse kinematic. आता inverse kinematics मध्ये काय करत होतो तर to find the position of end effector. Okay, to find the position of end effector, or the simply we can say that if I know the position of end effector, and from that we are finding the angles of each joint. प्रत्येक joint आपण काय करत होतो तर find out करत होतो. Similarly, in joint space planning also we are using the inverse kinematics to find the position of each angle. Okay, प्रत्येक angle ची पोझिशन हे फाइंड आउट करायचं असेल तर त्या केसमध्ये इनवर्स कायनेमॅटिक्स यूज करणार. देन द बेसिक प्रॉब्लेम इज हाऊ टू सिलेक्ट अ ट्रॅजेक्टरी बिटवीन अ गिवन इनिशियल and final joint position with the time interval allow the move between them. A simple straightforward approach could be to join the initial and final joint angles denoted with theta 0 at time 0, theta f at time tf, respectively, using straight line function which can be expressed as, okay, how can we represent any straight line person? theta t is equal to a0 plus a1 t. Okay, a0 is theta t0 and a1 is the this angle value. The next one is the where theta t is the joint angle at time t and a1 is the slope of the straight line shown in figure, which is constant. This implies the joint rate or velocity has constant value of a1 shown, where acceleration is 0 as indicated in figure. You can see here. Here you can the joint rate the joint angle with respect to the time, if it is changing, the slope they have shown here. Okay, joint rate and joint acceleration slope they have shown here. Next, okay, we have started our trajectory planning. Where we are, just I will go fast. Okay, we have seen what is mean by motion of the trajectory planning. Okay, after that we have started we have seen the joint space and Cartesian space. After that we have seen some of the related to that trajectory planning. Okay, next, first one is that in that we have seen the joint space planning for the, suppose you want to move the robot in a straight line manner, then for that here that equation it is a represent. ओके, त्यासाठी कशा पद्धतीने इक्वेशन असणार आहे तर त्या ठिकाणी ह्या ठिकाणी रिप्रेझेंट केलेलं आहे. ओके, सिम्पली वी कॅन राईट. ओके, सपोज एखाद्या स्ट्रेट लाईनचं जर इक्वेशन लिहायचं असेल तर हाऊ कॅन राईट सिमिलर फॅशन वी कॅन राईट फॉर द इफ यू वॉन्ट टू ट्रॅव्हल द रोबोट इन अ स्ट्रेट लाईन मॅनर. ओके, एखाद्या स्ट्रेट लाईन मॅनरने जर तुम्हाला मूव्ह करायचं असेल तर त्या केसमध्ये आपण काय करू शकतो तर वी कॅन राईट सिमिलर इक्वेशन्स अँड डिपेंड अपॉन द जॉइंट रेट अँड जॉइंट ऍक्सलरेशन वी कॅन राईट. नेक्स्ट वन इज द इफ इट इज क्युबिक पॉलिनॉमियल. ओके, आता स्ट्रेट लाईन साठी झालं. आता पॉलिनॉमियल एखादा कर्व असेल, ओके, तर त्या केसेसमध्ये काय करायला लागेल तर त्या ठिकाणी येतं. ओके, सिमिलरली you required one cubic polynomial equation like our theta t is equal to a0 plus a1t plus a2t square plus a3t cube. T is the time required, we can say that, and where we four coefficient a0, a1, a2 and a3 are calculated for the velocity and the acceleration condition at time t0, tf, that is initial condition time and final condition time. Okay, we can take the derivatives of that one and from that we can find out. Okay, to calculate coefficient first time derivative are obtained as, okay, if I take the derivatives of the this equation 12.1 a, then the value we get derivatives means we are finding the velocity of that joint. Okay, त्या joint ची आपल्याला velocity find out करायची. Okay, next, if I write in similarly matrix form, okay, linear algebraic equation, you will find such a format and from that you can find out the values. Okay, cubic polynomial and intermediate points. Okay, suppose if you want to find the intermediate points of that state space, okay, then in that case we can use such methodology, mathematical formulas to find out. Next, some of the example they have given. Okay, एक example like cubic polynomial with specified intermediate velocity. Actually this is not part they have not mentioned to solve the problems on this Cartesian and space test. Okay, यावरती कुठलेही प्रॉब्लेम नसणार आहे तुम्हाला जॉइंट स्पेस प्लॅनिंग आणि कार्टेशियन मध्ये. इफ यू सी युअर सिलेबस, ओके, सिलेबस जर बघितला तर डेरिवेशन न्यूमेरिकल एक्सरसाइज ऑन 2 degree of freedom and 3 degree of freedom manipulator means it is related to only forward and inverse kinematic. Then also just we will take the one problem, एक problem आपण बघूया how actually it is find out with the help of this joint space. Where it is, Okay, this one is the problem. Assume a robot joint has a move from initial condition they have given 0 degree, and at last condition is the 90 degree in 5 seconds. To travel from 0 to 90 degree, we required 5 seconds. For that, they have given the, and depend upon that we have to solve the problem. Okay, त्यासाठी आपल्याला solve करायचं आहे. Okay, you will get that. Again, if having order of 5, then how you can solve? Okay, the methodology is given. You can go through it and you can solve the problem. Okay, if they have given initial point and final positions. Okay, for that also, trajectory planning for 2-link planar are. Okay, if consist of 2 links, then in that case, how we can solve? Okay, suppose this one is the first link and second link, and for these we want to find the angle of each joint. Then how we can find? You can understood with the help of this one. For that, how we can take 2 degrees of freedom. Then we have to take the differentiation twice of that theta initial and final, and from that you will find the, as well as the programming also in such a manner it is done, the programming in the define the position in MATLAB. MATLAB मध्ये एखादं पोझिशन किंवा रोबोटची मुवमेंट जर हे डिफाइन करायचं असेल तर यू हॅव टू राईट द सच टाइप्स ऑफ प्रोग्राम इन द MATLAB. Okay, MATLAB मध्ये आपल्याला प्रोग्राम means initial condition and this one is the final position. To move this, okay, at 0 second time, theta 1 is the 90 degree, theta 2 is the minus 45. Theta 1 is the after 0.56 second, theta 1 is the 84.38, means theta 1 is going to reduce and theta 2 is increasing manner. You can see here up to the कुठपर्यंत increase होणार आहे up to 90 degree, and theta 1 it is reached to the 45 degree. Initial आपल्याला काय पाहिजे होतं तर theta 1 हा 45 degree पाहिजे होता, theta 2 हा 90 degree, means the position at initial such a manner after, okay, providing the timing, okay, you will get such a position. अशा पद्धतीने position तुम्हाला त्या ठिकाणी मिळेल. For that you can write such a logic, okay, and from that logic the movement accordingly it will move that. Okay, next one is the trajectory with give initial and several intermediate and final points. Okay, एक intermediate आणि भरपूर final point असते, तर त्या केस मध्ये आपण कशा पद्धतीने फाइंड आउट करणार हे तुम्हाला ह्या ठिकाणी बघायला. Okay, this is the extent of syllabus. This is not in our syllabus. Then also just I want to show you how that it is represented. Okay, now Cartesian. Only some introductory part of joint space planning and Cartesian space. Already we have discussed related to joint space and our joint space and the Cartesian. Only just we are taking the review related to that and the methodologies how to find out the angle between that joint space and the Cartesian space. Okay, you will understood that one. Next one is the Cartesian space. When a trajectory between two configuration of the robot generated by joint variables as described in the preceding section. Means we can say that if the motion between base and the end effector, base and the end effector, then we can go for the Cartesian space. It is sometimes difficult to predict the motion of the end effector. There are also cases in which some specific end effector trajectory is required. For example, arc welding electrode should follow a stream precisely. In such other cases, one may wish to generate a trajectory in terms of the position orientation of the end effector. There are several ways to describe position orientation, that is configuration of the end effector. Since the end effector is a rigid body in the three-dimensional Cartesian space, it has 6 degrees of freedom. 6 variables are required to prescribe the end effector configuration. Once the way is chosen, given point can be interpolated with sequence of says, okay, cubic or linear polynomial with the parabolic blends and then joint trajectory above section. Okay, this is about the Cartesian space. Okay, suppose if you want to find the space, आता ह्यामध्ये काय असणार आहे तर एक ओरिजिनल बेस असेल आणि सेकंड म्हणजे काय असणार आहे तर सेकंड म्हणजे एंड इफेक्टर. हा बेस असेल, सपोज 2 लिंकचा रोबोट आहे तर त्याचं काय करणार आहे तर इन कार्टेशियन टू फाइंड अ पाथ, ओके, पाथ फाइंड आउट करायचं असेल तर एक काय असणार आहे तर बेसला 0 मानलेलं आहे किंवा इट इज फिक्स्ड ऍट origin and this one is the movable at t time 2.0. ओके, 2 पॉइंटला काय येतं हा एक्स ऍक्सिस वरती आहे. तर आफ्टर 1.5 it will reach to here, or the suppose at initial our robot end effector is here, then as time goes on increasing, okay, you can see here the motion of each link. प्रत्येक लिंकची मोशन कशी झालेली आहे तुम्ही त्या ठिकाणी. इट इज नॉट इन दिस कार्टेशियन वी आर नॉट डिस्कसिंग अबाउट दिस अँगल्स. ह्या 2 लिंक मधला जो काय अँगल आहे ह्याबद्दल आपण काही विचार करत नाही. फक्त ह्या 2 लिंक मधला किंवा एंड इफेक्टर आणि बेस मधल्या कशी मोशन आहे तर ते त्या ठिकाणी आपण फाइंड आउट करतो. ओके, दिस इज सम ऑफ द फॉर्म्युलाज. ओके, फ्रॉम देट वी कॅन फाइंड आउट. ओके, trajectory of end effector orientation. Okay, how would that find out? Okay, you will find out with these formulas. Okay, this is about our third unit. If you have any problem in this unit, you can ask directly to me. Okay, ह्यामध्ये या तिसऱ्या युनिट मध्ये पुन्हा प्रॉब्लेम असेल तर विचारू शकता about the kinematics, dynamics and trajectory plan. We have covered all points from these 3 units. Okay, most probably today evening I will share one test on this our third unit. तिसऱ्या युनिट वरती एक टेस्ट शेअर करेन. You have to solve, you have to solve that test. Okay, because mostly numerical part on, if you see our whole syllabus, in third unit only you will find the numericals, and other units are, it is related only theoretical units. You have to see the sum of the formulas and the problems. It is related to only forward kinematics, inverse kinematics. Forward आणि inverse kinetic बद्दलच तुम्हाला त्या ठिकाणी प्रॉब्लेम बघायला भेटतील. Others there is no any problems in this subject. Okay, if you have any problem you can ask up to the trajectory plan. Okay, all syllabus are completed from my side. Okay, माझ्या साइड ना जेवढा काय पॉइंट कव्हर करता येईल तेवढे सगळे पॉइंट मी कव्हर केलेले आहे. इफ यू हॅव एनी प्रॉब्लेम, क्वेरीज, हिअर आफ्टर यू कॅन कॉल मी अँड फॉर क्वेरीज यू कॅन आस्क मी. ओके, एखादं प्रॉब्लेम क्वेरीज असेल तर आपल्या रोबोटिक्स बद्दल तुम्ही कॉल करून विचारू शकता. आय एम रेडी टू गिव्ह द आन्सर रिलेटेड टू दॅट. नाऊ this end of our robotics and artificial intelligence. And one more request from my side, all are requested to write the assignments, okay, which is I have provided 6 assignments. You have to complete that assignments and you have to upload on that submission link as early as possible. And one more instruction from my side related to exam form. Okay, those have yet not filled the exam form, please fill it on urgent basis, because exam will start from, backlog exam will start from 24th. Okay, 24 तारखेपासून एक्झाम स्टार्ट होणार आहे. तर त्यासाठी सगळ्यांनी लवकरात लवकर, ज्यांनी भरलेला नसेल तर त्यांनी एक्झाम फॉर्म फिलअप करा. ओके, दिस इज फ्रॉम माय साइड. Okay, all about the robotics and artificial as well as the from instruction, okay, administrative instruction from my side. Okay, if you have any queries you can unmute yourself and you can ask. Otherwise we'll end our session, today's session. No queries? Okay, if you have no queries you can write your roll numbers in chat box and you can leave the meeting and join the rack.